Yes, it's possible to temporarily replace a lower amperage panel with a higher amperage panel, even if the service entrance is rated for a lower amperage. However, it's important to understand the implications and safety considerations. Firstly, turn off the main power at the meter. Secondly, disconnect the service entrance cables from the old panel. Thirdly, install the new 200 amp panel and connect the service entrance cables to it. Fourthly, turn on the main power at the meter. The amperage rating of the panel itself does not dictate the amperage of the service entrance. The service entrance determines the maximum current available from the utility. Installing a 200 amp panel on a 150 amp service doesn't magically increase the available current. There are crucial safety concerns to keep in mind. 1. If you have appliances or circuits that draw more than 150 amps, the main breaker will trip. 2. Overloading the panel by drawing more current than it's rated for could lead to an electrical fire. 3. Insurance companies might have concerns about a panel with a higher amperage rating than the service entrance. Ideally, the service entrance should match the amperage rating of the panel. This ensures you have the maximum current available and minimizes the risk of overloading. If your electrical demand is guaranteed to stay below 150 amps for at least a year, temporarily replacing the panel is a possibility. Electrical work can be hazardous. If you're uncomfortable with any part of this process, it's highly recommended to hire a qualified electrician. They can ensure the work is done safely and according to code. It is also very important to ensure you follow lockout-tagout procedures when working with electrical equipment. This process involves completely de-energizing a piece of electrical equipment, locking the disconnect, and tagging it to indicate that work is being performed on the circuit. The purpose of this is to prevent accidental energization of the circuit while you're working on it. Always double-check that the circuit is de-energized prior to touching any wires. Verify that the voltage is zero using a calibrated voltage tester. Working on a live circuit can result in electric shock or death. When you are working with electricity, it is absolutely critical to wear the proper personal protective equipment, or PPE. This includes safety glasses, insulated gloves, and appropriate clothing. Safety glasses will protect your eyes from flying debris and arc flashes. Insulated gloves will protect your hands from electric shock. Wear non-conductive clothing made from natural materials like cotton. Avoid wearing any metallic jewelry or accessories, as metal is a good conductor of electricity. If you're unfamiliar with any of these steps, consult a qualified electrician before proceeding. Always follow the electrical code. The National Electrical Code, or NEC, sets standards for safe electrical installations. It covers everything from wire sizing to overcurrent protection. Always consult the NEC before doing any electrical work to ensure that your installation is up to code. Some common NEC requirements include proper grounding and bonding of electrical equipment. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker in the event of a fault. Bonding connects all metallic parts of the electrical system together to create a low impedance path for fault current. All electrical boxes must be properly grounded. This includes metal boxes, plastic boxes, and receptacle boxes. Use a grounding screw or a clip to connect the grounding wire to the box. When installing wiring, use the correct wire size for the circuit. The wire size must be large enough to carry the anticipated load without overheating. Consult the NEC for proper wire sizing based on the circuit amperage and wire insulation type. Electrical connections must be properly made and tightened. Loose connections can cause arcing, which can lead to fires. Use wire connectors that are rated for the size and type of wire you are using. Make sure the connections are tight and secure. Use the right type of overcurrent protection device for the circuit. Overcurrent protection devices, such as circuit breakers and fuses, protect the circuit from overloads and short circuits. Use the correct size and type of overcurrent protection device for the circuit. Overcurrent protection must be properly sized to protect the circuit from overload. An overload is a condition where the circuit is drawing more current than it is rated for. If the overcurrent protection is not properly sized, it may not trip during an overload, which can lead to overheating and fires. Also, remember that when performing electrical work, do not work alone. Always have someone nearby who can assist you in case of an emergency. If you do get shocked, the other person can call for help and provide first aid. Always work in a well-lit area, as this will help you see what you are doing and avoid making mistakes. Poor lighting can lead to accidents and injuries. Remember to use the right tools for the job. Using the wrong tools can damage the equipment and increase the risk of injury. Use tools that are insulated and in good working condition. Plan your work ahead of time. Before you start working on any electrical project, take some time to plan out your work. This will help you avoid making mistakes and ensure that you have all the necessary materials and tools. Consult with a qualified electrician if you have any questions or concerns. When working with electrical systems, it is always best to err on the side of caution. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. One key aspect is grounding and bonding. Grounding ensures a safe path for fault current. Bonding connects metallic parts, creating a low impedance path. All electrical boxes must be grounded using grounding screws or clips. The correct wire size is crucial for safety. Wire size must handle the anticipated load without overheating. NEC tables provide guidance based on circuit amperage and insulation type. Proper electrical connections are essential. Loose connections cause arcing and fires. Wire connectors should match wire size and type. Connections must be tight and secure. Use the correct overcurrent protection. Circuit breakers and fuses protect against overloads and short circuits. Use the right size and type for the circuit. Overcurrent protection needs proper sizing. Overloads occur when circuits draw too much current. Undersized protection won't trip, leading to overheating and fires. Also, be sure to never work alone. Have someone nearby for emergencies. If you get shocked, they can call for help and provide first aid. A well-lit work area is essential. Poor lighting leads to mistakes and accidents. Proper tools are a must. The wrong tools can damage equipment and increase injury risk. Use insulated tools in good condition. Plan your work thoroughly. This helps avoid mistakes and ensures you have the right materials and tools. Always consult a qualified electrician for questions or concerns. Safety should be the priority in electrical work. Consider the potential for arc flash when working with energized equipment. An arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and even death. Wear appropriate arc-rated personal protective equipment, or PPE, when working on or near energized equipment. Arc-rated PPE includes a face shield, gloves, and clothing that are designed to protect you from the heat and energy of an arc flash. Another thing to remember is to be aware of confined spaces. Working in confined spaces can be dangerous due to the risk of electric shock explosion and exposure to hazardous materials. If you must work in a confined space, make sure to follow all safety procedures and use the appropriate safety equipment. Remember to always inspect your equipment before use. Before you use any electrical equipment, inspect it carefully for damage. Look for frayed cords, cracked insulation, and loose connections. If you find any damage, do not use the equipment and have it repaired or replaced. Avoid water when working with electricity. Water is a good conductor of electricity, so it is important to avoid working with electricity in wet conditions. If you must work in a wet area, use a ground fault circuit interrupter, or GFCI, to protect yourself from electric shock. Also, remember to turn off the power before working on any electrical circuit. This is the most important safety precaution you can take. Before you start working on any electrical circuit, turn off the power at the breaker box. This will prevent you from getting shocked. Using a non-contact voltage tester to confirm that the circuit is de-energized. The tester will detect the presence of voltage without you having to touch any wires. This is a safe and easy way to verify that the circuit is de-energized before you start working on it. When choosing wire connectors, consider the type of wire being used. Different types of wire require different types of connectors. For example, aluminum wire requires different connectors than copper wire. Using the wrong type of connector can lead to corrosion and failure of the connection. Also, be aware of the torque specifications for electrical connections. All electrical connections must be tightened to the proper torque specification. This ensures that the connection is secure and will not loosen over time. Use a torque wrench to tighten the connections to the proper torque. When working with electrical boxes, be sure to use the correct size box for the number of wires and devices that will be installed in the box. Overfilling a box can lead to overheating and fires. Use a box fill calculation to determine the correct size box for your application. When installing electrical receptacles, be sure to use tamper-resistant receptacles in areas where children are present. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the receptacle. When working with electrical panels, be sure to label all of the circuits clearly. This will make it easier to identify the correct circuit when you need to turn off the power. Use a circuit directory to list the circuits and their corresponding loads. When you upgrade your electrical service, consider the future needs of your home. Choose a service size that will be adequate for your current needs and any future appliances or equipment that you may add. Also, consider the location of the electrical panel. The panel should be located in an accessible area where it will not be exposed to moisture or damage. Consider the layout of the wiring in your home. The wiring should be installed in a neat and organized manner. This will make it easier to troubleshoot any problems that may arise in the future. Also, consider the type of wiring that is used in your home. The wiring should be appropriate for the application and should be in good condition. The NEC addresses various wiring methods. Firstly, non-metallic sheet cable, or NM cable, is commonly used in residential wiring. Secondly, armored cable, or AC cable, provides added protection. Thirdly, conduit, such as EMT or PVC, offers the highest level of protection. It is important to select the appropriate wiring method based on the application and local codes. The NEC specifies requirements for GFCI protection in various locations. GFCI protection is required in bathrooms, kitchens, garages, and outdoor areas. GFCI outlets trip when they detect a ground fault, which can prevent electric shock. It's crucial to understand grounding electrode systems. A grounding electrode system provides a path for fault current to flow back to the source. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes, also known as UFA grounds. The NEC specifies requirements for the size and installation of grounding electrodes. The NEC includes requirements for surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD should be installed at the service entrance and at branch circuits to provide comprehensive surge protection. Also, be mindful of arc fault circuit interrupters, or SIs. SIs protect against arc fault, which can cause fires. SIs are required in many locations, including bedrooms and living rooms. An arc fault is an unintentional electrical discharge that can occur in damaged or worn wiring. When working on electrical projects, always follow the manufacturer's instructions. The manufacturer's instructions provide detailed information about the installation and operation of the equipment. Following the manufacturer's instructions will help to ensure that the equipment is installed correctly and will operate safely. In addition, be sure to keep your electrical panel clean and free of debris. Dust, dirt, and other debris can accumulate in the electrical panel and can cause overheating and fires. Clean the electrical panel regularly with a vacuum cleaner or a soft brush. When replacing a circuit breaker, be sure to use a breaker that is the same size and type as the original breaker. Using a breaker that is too large can overload the circuit and can cause a fire. Using a breaker that is too small can cause the breaker to trip unnecessarily. Also, consider the use of energy-efficient lighting. Energy-efficient light bulbs use less energy than traditional light bulbs, which can save you money on your electricity bill. Consider the use of LED lighting, which is even more energy efficient than CFL lighting. Finally, be sure to keep your electrical system properly maintained. Have your electrical system inspected regularly by a qualified electrician. This will help to identify any potential problems and will ensure that your electrical system is operating safely and efficiently. When choosing an electrician, make sure that they are licensed and insured. A licensed electrician has met the requirements of the state or local jurisdiction and is qualified to perform electrical work. An insured electrician has insurance that will protect you in case of any accidents or injuries. Always get a written estimate before hiring an electrician. The estimate should include a detailed description of the work that will be performed and the cost of the work. Also, be sure to get a warranty on the work that is performed. The warranty should cover any defects in materials or workmanship. Remember, electrical safety is critical. Taking the necessary precautions will help to protect yourself and your family from electric shock and fire. Always prioritize safety when working with electricity. When dealing with aluminum wiring, remember that it requires special handling. Aluminum wiring expands and contracts more than copper wiring, which can lead to loose connections. Use connectors that are specifically designed for aluminum wiring and follow the manufacturer's instructions carefully. Also, consider the use of antioxidant paste to prevent corrosion. Also, consider the use of whole house surge protectors. These devices protect all of the electrical equipment in your home from voltage surges. They are typically installed at the service entrance and can provide valuable protection against lightning strikes and other electrical events. When selecting a whole house surge protector, choose a device that has a high surge current rating. The surge current rating indicates the amount of current the device can withstand during a surge event. Also, be mindful of ground resistance testing. Ground resistance testing measures the resistance of the grounding electrode system. The resistance should be low enough to allow fault current to flow back to the source. Ground resistance testing is typically performed by a qualified electrician using a ground resistance meter. When you are troubleshooting electrical problems, start by checking the circuit breakers. If a circuit is not working, the first thing you should do is check the circuit breaker. Make sure that the breaker is not tripped. If the breaker is tripped, reset it. If the breaker trips again immediately, there is a problem with the circuit and you should call a qualified electrician. Also, be aware of the dangers of overloaded circuits. An overloaded circuit is a circuit that is drawing more current than it is designed to handle. Overloaded circuits can overheat and cause fires. To prevent overloaded circuits, avoid plugging too many appliances into the same circuit. Also, consider the use of multi-outlet power strips with built-in circuit breakers. Consider electrical inspections. Electrical inspections are performed by qualified inspectors who check the electrical system for safety and code compliance. Electrical inspections are typically required when you are buying or selling a home or when you are making significant changes to the electrical system. Before commencing any electrical work, verify local regulations and permits. Many jurisdictions require permits for electrical work. Check with your local building department to determine the permit requirements in your area. Obtain all necessary permits before starting any work. It's crucial to maintain accurate records of all electrical work performed. Keep records of permits, inspections, and any repairs or upgrades that have been made. These records can be helpful when selling the home or when troubleshooting electrical problems. Regarding electrical safety audits, these audits can help identify potential hazards in the electrical system. A qualified electrician can perform an electrical safety audit and recommend corrective actions. Safety audits are particularly important in older homes or in buildings with complex electrical systems. When addressing electrical issues, prioritize repairs over temporary fixes. Temporary fixes can be dangerous and may not comply with code. Always repair electrical problems properly and use qualified electricians.